Hello, good day, and welcome to my channel. Today, we are going to look at the Outseal Studio for learning how to program ladder logic. And we are going to do a simple demonstration of how you can program ladder, program PLCs, of course, the microcontrollers using uh, the ladder diagram. The Outseal Studio, the developers are from Indonesia, so it's available in Indonesian and also English. The English translation is not the best, but yes, it's sufficient for uh, what you would need it for, I guess. And here is the software environment. You can easily download this. It's available for free. Just go to the official website, Outseal Studio, and just type on your browser Outseal Studio and look for the official website and download it from there. It's available in Indonesian and also in English. So it's already in English. Like I said, the translation is not perfect, but it's sufficient. For example, here is instructie. I guess this means instruction, but and also here, I don't know what this means, but yeah, it's there. But aside from that, it's enough for you to get the job done. Here we have settings, and these are different hardwares that are supported: Mega, V1, Compact, App, Nano, and all that. So that is that. So you can use this to learn your PLC, how to program PLCs using ladder diagram, and you can connect your PLC, your Arduinos to it, and have it programmed. Now, there's a simulation environment in case you don't have a physical hardware, but you want to learn programming. There are three options here. There is the basic option, there's the water pump, there's PID. Today we're going to look at the water pump. The PID has to do with, I think, a cooling system, a circulation system with a set point, current value, and what have you. But we're not looking at that today. Today we are looking at the water pump. And with this water pump, let's get to the basics of how to program using ladder diagram. Here we have switches. So your PLCs have inputs. The inputs are called, in this case, they're called switches, and it also has outputs. The outputs are called relays. Okay, that is, your output devices are connected to relays. If you look here, you would see that we have, this is an Arduino Nano. Here is an Arduino Nano. It's connected to this board. This board has some relays. Your Arduinos work with 3.3 volts and 5 volts. So under 5 volts, generally, but sometimes your output devices can work with 12 volts, 24 volts, 240 volts, and what have you. And you don't want to connect them directly to your board. If not, you're going to destroy the board. You're going to fry it. And so you have your inputs and your outputs. So side by side, you have a Siemens PLC, and this Siemens PLC, this is the 1200 series. This is designed for industrial environment, and of course, it's more robust. The materials of construction, everything is robust, and the safety considerations in this, the electrical safety, electromagnetic compatibility, and all that, they've been taken into cognizance, into consideration in building them. All the ULs, standards, safety standards, and all that have been, considered in building this. So this will over time should outlast this, but this can get the job done. But this is made for this work. But this is very, very, very expensive. It's much, much, much more expensive than this. So if you are tight on a budget, you can go with this one, and you can learn to program using something like this. So now let's go and see how we can run a simple program. Now, like I said before, here's our simulation environment. We're going to do this simulation, but we're going to take it first thing at a time. Now we have this is called the ladder. This is why it's called the ladder diagram. We have these two here are called the rails, and this is the rung. So the rails and the rung. Here is basically the positive side of it. Current flows from from left to right, and here is the ground or the common. This is the ground. So you can add more rungs, can add more rungs. You can see the number, so adding it, the number is increasing. And because you can delete them or you undo what you have done. So basically that is that. Now what we have is this. We have an on button, we have an off button to fill this tank. We have switches S1 to S5 to determine the levels. Now let's say, for example, we want the running light to come on. We want to put on this running light. If I press on, I want this running light to come on. What am I going to do? On is a switch, S6. So I'm going to put my switch here. I come here and put my switch. Now I go to my bit, normally open. Okay, I drop it here. It's a normally open switch. And it's asking me, what switch am I talking about? I'm talking about switch S6. So I'll come here, I go to my switch, and I look for S6. I take S6 and I drop it here. Okay, now what is this switch controlling, or what do I want to control with this switch? I want to control the running lights. I want the running lights to come on. That is R2. And the R2 is a relay, it's an output coil. It's an output coil. Okay, if you go back to this place, you see that we have relays here. So it's an output coil. I want it to control this output. Now we'll go back to here and I'll take my output. This is my output coil. I take it and I can just add it to this place. It will bring it to this right hand side. And it's asking me, what output coil am I talking about? I'm talking about output R2. So I go to relay and I take R2 and I drag it here and I leave it. So I've done a simple connection between my S1 and S2. If I press my S6 rather, my R2 should come on. That is, if I press this, it should come on. Now to do that, I need to test my program if it's okay. No mistakes, we are fine. We are good to go. So I'll go on to my simulation. When I go to my simulation, you can see here is hot. Here is hot now because we're on a live simulation, it's hot. But because of it is a normally open contact. Normally open contact means that normally when you have not pressed it, when you have not energized this switch, the circuit is open. That's why it's called normally open. So you don't have me to close the circuit, I need to energize it. How do I energize it? By pressing it. So I press it, it's closed. Now if I close it, the current will continue to flow and to get to this output, which is the R2, which is the running light. So if I press on, you can see the light has come on briefly. So I need to press it again. Now, you can see, for me, in order for the light to remain on, I need to keep pressing it. So this kind of switch is called a momentary push button. This is a momentary push button. That is, if I press it and release it, the light will go off. So in order for me to keep it running, I need to keep pressing it. Okay, but this is not practical. It's not practicable. So what I need to do is find a way to press it once and this light will keep coming on. And one way I can do that is called latching, circuit latching. So we need to latch this circuit. Now to latch the circuit, what I'm simply going to do is I'll come here, I'll come to this place and I create a branch here. I create a branch here. And to do that, I go to my design. I need to leave the simulation environment and go to the design. And when I come here, I need to create this branch. And how do I create the branch? I just go to basic and you see wrong branch. I can drop it here, for example. This switch, I don't want this switch to be here. I want the switch to be here. So this switch, I drag it to where I want it to be. So I want it to be there. I leave it. So it's there. Now I want to create a latching circuit. So what I'm going to latch, what's the logic behind this latch? Okay. Now, when I press the switch, this comes out. So I want to use this output, this bit, this output here to hold it. That is, when this one is on, if I put the same R2 here, this will be on. And because this is on, this will continue to be on. So what I'm going to do is I'll take this R2 bit and put here. So I go here, take my R2, drop it here. Okay, so this is what we have. Now I'm going to test it and see if we are okay. Test, no mistakes, we are fine. Simulation, I go on to simulate it. Now let's allow the system settle. Okay, yeah. Now I can press on. So when I press on, you can see the light is on. If I press on, you can see the light is on. Continuously, it's on. Now, because this, as it's on, this place is on. Because this is on, the current will flow, so it's continuing to be on. Now, how do I stop it? To stop it, I need to put on off switch. So I put an off switch here, and I make it normally closed instead of normally open. So mostly when you are programming and using your stop buttons mostly, not all the time, but mostly your stop buttons, your emergency stop buttons are usually wired normally closed. Now you're going to take this normally, you're going to go back to the design environment. We are leaving the simulation environment. We are now in the design environment. I'm going to add a normally closed contact. So this is a normally closed. Okay, and this normally closed is going to be the switch. S7, which is the off button. So S7. So here I'm going to put S7. I'm going to switch, look for S7, and I will drag it and drop it there. So S7. So it means that now we can stop it. So all I have to do now is say test. If we are okay, we are okay. Then go to simulation, and also let's allow this empty itself. And now we can start. So when I start here, press on, you can see the running light is on. If I press off, the running light is off. If I press on, it's running. If I press off, it stopped. So the same thing. Now the next thing is, what do I want to do? When this light is running, what should happen? This pump should start working. This pump should start working. And then I need to go back to my design environment, reset this one to empty, then add a new rung. So I want to use this signal, okay, this bit, to control the pump. So I put a normally open contact here. I put an output here. This normally open contact wants to be R2. So I go to R2. I drop it here. And this one, I want it to be the pump, R1. Okay, R1. So we are good to go. If I test it, we should be fine. No mistakes. We'll go online. No mistakes. Press on. So you can see it's working. It's moving. So it's on. So this is a simple way. You can say the pump is on, but the pump is not stopping. It's working. It keeps working. But we don't want it that way. We want it, for example, maybe when it fills and gets to S2, it should stop. So to do that, for it to fill and get to S2 and stop, all you have to do now is we go back. Let's stop this, put off the system. You can say we have put it off. It's going down. It's emptied. Okay. Now I'm going to stop this simulation and go to design. So go to design menu. Let's reset this and make this empty, for example. And simply put, I want it to fill to S2 and stop. So I'm going to put something here. I'm going to put a normally closed contact here for this switch button. That is, when it's full, the circuit should be open and it shouldn't allow this to run anymore. So basically, that's what I'm going to do. S2. So we'll go to switch. Take S2, for example, and drop here. So we have our S2, switch 2, okay, so it should be fine. Okay, now let's go online. Okay, reset and on. Let's go. So you can see it's going to fill when it gets to S2. So S2, it has stopped, but you can see it's going on and off, on and off, on and off. Look at this pump. This pump that is doing something like this, it's going to take a very short time for it to burn up because it's going on and off, on and off, on and off. That is because this running light is on. And because the running light is on, and it gets to this place, it stops. This tap is on. This tap is always bringing out water. So when it gets to this level, it stops. The level drops. Because the level has dropped beyond this place, the pump starts working again. It gets to this place, it stops. So it's doing this. The cycle time is very, 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 very short. So if you run your pump like this, the pump is going to burn. So you need to design it in another way. So to design it another way, we'll go back. Or should I stop and make this as maybe as a tax? Someone tell me what is the best way we can do it so that we minimize this on-off motion of the pump and preserve this pump, save this pump from burning. Someone tell me in the comments how we can do that. Let me just stop here, and we'll see in our next class. Thanks, and have yourself a lovely day. Auf Wiedersehen. Tschüss.